am Professor Prabhu Rajagopal with the Department of Mechanical Engineering at IIT Madras. Thank you, Ritesh, for having us over here in your special feature. So I am here today to talk about our work on trying to mechanize the process of scavenging in septic tanks and sewer lines. We've been working on this for several years now, but the key turning point for us was about 4 years ago when, through the efforts of an organization, NGO called Safai Karamchari Andolan, we went to interact with the manual scavenging workers. We found that it was shocking to see that even today this practice is continuing. There were many widows of people who had died in this scavenging work. We met people who had lost eyesight, nails or hair and so on. It was quite a poignant moment for us. And to me personally, I think we are as a country, we're a $3 trillion economy. We have nuclear weapons. We can send probes to Mars and Moon. But it is very shocking that this is something that we are allowing to happen. We are allowing young people to go and die in septic tanks and sewer lines. So we came back and we really wanted to make a difference here. But sadly, at that time, we neither had funding nor were there any people as such. Gradually, as they say, a little idea that is seeded gradually grows into a big tree. So we kept trying little by little. We got initial support from IIT Madras through a program called Socially Relevant Projects. Then we got support from the Carbon Zero Challenge in 2019, at which point Divanshu joined on board with us. Divanshu wanted to work on a socially relevant problem. Here was a challenge and he took it head on, especially after the meeting with the Safai workers, which impacted all of us equally. So in doing this, we had to overcome several technological challenges because we found out that the septic tank fluid is actually not what we call a Newtonian fluid, use a technical term. It's a thixotropic fluid. That means the more you stir it, the harder it becomes as such. So we also did not have any equipment to handle this toxic material. So Divanshu set about creating equivalent materials which we can create in the laboratory. And in this process, we got support from several faculty members at IIT Madras. Professor Liji Philip, who is now our Dean Planning, helped us with connecting to NGOs. We had Professor Diman Chatterjee, whose connection brought us SKA, Safai Karamchari Andolan. Professor Abhijit Deshpande, who helped us test these septic tank mimicking materials in his rheology laboratory. Gradually, in the industry and the government was also noticing. We received support from the Wind Foundation first. Divanshu won the National Bio-Entrepreneurship Challenge for this project through the Wind Foundation. Later, Gale Foundation and Capgemini Foundation came to support us to productize this solution. In the last 1 year, we have had support from NSC Foundation and L&T Technology Foundation to make and distribute these robots. Also, over the years, several government agencies have taken notice of our work. Recently, Solinas is a startup that Divanshu is now heading, that is now taking this product and technology to the field. So Solinas has been in a lot of interaction with several government ministries, as Divanshu will talk about. Solinas is involved in water and sanitation in general. For us also, the support from the Office of the Principal Scientific Advisor to Government of India is very crucial. They coordinate work from several ministries, and they have been following our work with a lot of keen interest over the years. Ministry of Social Justice, Ministry of Water Resources, which is the Jal Shakti Ministry now, Ministry of Urban Housing, they are all looking at our work very keenly, and once a solution reaches the right point, they all want to have a handshake to take it forward as such. So with those words, I hand over the baton to Divanshu to continue.
Thank you, Professor. I think he probably summarized the journey so far. I'll talk about the moment that we had in 2018 mid, when we actually met the Safai Karamcharis and had the interaction to understand the problems that they faced. And for me as a student, this was a defining moment where I thought that this is something that I should be solving. And hence, I really took on the project seriously, tried to think what are the principles because of which the problem in the septic tank happens. And based on that, from a first principle thinking, we designed certain solutions in terms of inverted umbrella mechanism or multi-blade system or feeder system, through which we were able to develop a solution That got us certain accolades. At the same time, the most important thing was that it gave us good feedback from the Safai Karamcharis themselves that this product can work into the market. And that was something that was very crucial for us. Over a period of time, as I developed the first prototype, and then Bhavesh, who now heads the technology aspect of sanitation, joined us in developing the commercial ready Homosep right now. We have built a team who is able to engineer solutions and solve the actual problems for the Safai Karamcharis there. We also took this to the next step while actually incorporating a company along with the professors named Solidus Integrity, whose focus now is to develop technologies for the water and sanitation industry and solve the problems that is generally faced by people. Homosep is a product out of that, and we have received several support from various entities to take it to in the hands of Safai Karamcharis, in the hands of corporations, and all those people who will actually essentially help us in eliminating manual scavenging from septic tanks.
So coming to Homosep, Homosep consists of 4 major modules. First is bottom module. Bottom module consists of umbrella mechanisms and the multiple blade, which helps to homogenize the hard sludge of the septic tanks. Then the second module is the feeding system, which take the entire bottom module to the depth of the septic tank, so we can achieve the homogenization at various high depths of the septic tank also. Third system is the portable system, which mount entire robot on a treadmill, so that our system should be very portable to take any sites of the septic tank. And fourth unit consists of the suction system. Once we homogenize, this suction system helps us to take the slurry outside the tank.